let's take a look at this sequence as an example. So is there any pattern of this sequence? Well, it is. The pattern will be the term increases by 2. So 2 will be the common difference. From the previous lesson, we have learned that a sequence with a common difference will be an arithmetic sequence. So there is a general rule for finding the nth term of an arithmetic sequence. That will be a sub n equals to the first term plus n minus 1 times the common difference. Okay, so in this case, you want to plug in the first term with 1 and d with 2. Okay, so if you rewrite this expression, you got a sub n equals to 2 times n minus 1. So we can fill in this blanks. 2n minus 1. Okay, with the general rule of nth term is easy to find a sub 7, a sub 16, and a sub 134. Okay, so if you want to find a sub 7, let's replace n with 7. So that will give you 2 times 7 minus 1, which is 13. Okay, use the same idea to find a sub 16 and a sub 134. So that will be 31 and 267. Okay, and now we need to find the sum of the first 16 terms of this sequence. So how will we do that? Well, there's a shortcut. If you find the general rule for finding the nth term, the first nth term of this sequence, which is written as the sum s sub n. If you can find the rule for the sum sub n, well, you can find this. You can find the sum of first 16 terms of this sequence. Okay, so we know this for any arithmetic sequences, this equals to what? This equals to the mean of the first and the nth term times the number of terms. Okay, so that will be the formula for finding the first nth term of an arithmetic sequences. Well, in this case, let's plug in the first term with 1. Okay, and a sub n, we know that it is 2n minus 1. And this times n. Okay, so if you simplify this expression, it is equals to n squared. Okay, so with this, you can find the sum of the first 16 terms of this sequence. So you just need to plug in n with 16. So that will give you 256.